Imagine your data, AI data to be exact. Data comprised of billions of pulses of light that travel over and across the internet, carrying information derived from intelligence that is critical to your business. If your business relies on real-time data delivery arriving at a second's notice, without quick crash or system failure, Supermicro is the clear choice, delivering extreme performance with Petascale all-flash NVMe storage to support proven architectures for AI and ML workloads, with leading software-defined storage platforms. If you're an enterprise business, government agency, or in the education and research sector building a public cloud, private cloud, or generative AI supercluster, there's only one choice. And that choice can only be exactly the best.
Hello, and welcome to this session of the Supermicro Open Storage Summit on enabling AI data pipelines, optimizing storage for AI. I'm Rob Strechay, Managing Director with theCUBE Research, and your moderator for this special session. As companies look to better leverage Gen AI and traditional AI, we see organizations are trying to get a handle on what is the right data to use and what data platform and storage they should be provisioning. AI storage has to service a number of different workloads. Many of these workloads depend on the different stages data goes through when being prepared for AI. Those steps usually include data cleansing, data transformation, data aggregation, feature engineering, feature extraction, data visualization, and data integration. All of this is done before you can even get to train your model. This will differ slightly if you're using a pre-trained foundational model, such as grounding and fine-tuning the model are really what you're focused on. The most popular production use cases seen in our research are text and data summarization, code generation, and writing or content marketing. Most companies will be leveraging their Gen AI infrastructure by training and fine-tuning existing foundation models on their company's corporate data, which is their intellectual property. Now, before we jump into a discussion, we would like to let you know that all the material you're about to see from the partners is going to be available on the session link on the registration website on thecube.net after this is done. And the speakers will be live on X to take your questions. Use the hashtag SupermicroStorage2024, all one word, to ask questions. Now, let me introduce our speakers today. Rob Davis, who's the VP of Storage Technology at NVIDIA, Jon Toor, who's the CMO of Cloudian, Shimon Ben-David, who's the CTO at WekaIO, Steve Hanna, who's the Head of Product Management High Capacity NVMe SSDs for Micron, and William Lee, who's the Director of Solution Management, Supermicro. Now, let's jump in and get to know the companies a little bit better. First off, let's jump to Rob, who's going to kick us off here.
Thanks a lot, Rob, and I like your name, by the way.
Yeah, very popular.
First of all, I want to thank Supermicro for thinking about NVIDIA and letting us be a part of the Open Storage Summit. That's really great. What I'm going to talk about is where NVIDIA is today from the perspective of storage networking for AI and where we're thinking of going in the future. So let's start off with the GPU servers, of which Supermicro is one of our partners for building those, and we really appreciate that. And we're going to start with the local SSDs. And they're important, even though they're not networked, because a lot of the applications for AI today actually load the data set into those SSDs and then run off of the local SSDs. Now, as AI has expanded, and it's expanded greatly, now more often than not, in fact, the data sets don't fit in one GPU server's memory. So that's where the memory that's remote network storage comes in. And that can be, in the petabyte amounts nowadays. And to do that, we have to have a network. And we have networks from NVIDIA that are also supplied by Supermicro, including switches and adapters in both InfiniBand and Ethernet. And those are connected through all the way into the GPU servers using a technology called GPU Direct Storage. And what GPU Direct Storage does is eliminate the interface to the local CPU and move data directly from the storage, from the network storage, into the GPU memory. So now let's look at some of the things we're looking at for upcoming technologies in this area. The first of all is moving to 800 gigabit networking. So GPUs need to be fed, and they need to be fed lots of data. And if they're not being fed data, they're sitting idle, and they're expensive. So you want them to have as much data as they need when they need it. So that's why we're moving to the next speed bump, which is 800 gig. Our storage partners like Weka, who's also on this panel, are moving with us, as well as our other storage partners. In fact, Supermicro is a storage providing components as a storage partner. And they'll be moving to 800 gig. We're starting to put products in the market at 800 gig later this year. And that'll be across the board, switches, whether they're InfiniBand or Ethernet, as well as adapters. And then something else we're looking at is object storage. And Jon from Cloudian on this panel will talk more about that. But what we're seeing is that, I mean, this is pretty well known. Most of the data in the world is stored actually in object format, not block and file. And so moving that data as efficiently as possible to keep those GPUs busy is a very important thing. And so we're going to focus on how to do that, and you'll see things coming out in the future in that area. The last thing I'm going to talk about is Spectrum-X. Now, Spectrum-X is a technology that we've introduced already and is widely talked about from the perspective of clustering the GPU servers. What it's designed to do is be as close to InfiniBand performance as possible. All of our partners, our storage partners, or most of our storage partners use InfiniBand or Ethernet. And what this does is get that Ethernet performance for customers that are not interested, for whatever reason, in InfiniBand, as close to possible of that performance. And here's an example. So this is the latency you see with Spectrum-X on an Ethernet network. And this is a normal Ethernet network. The only thing you have to change is make sure that you have NVIDIA Spectrum 4 switches and DPUs or SuperNICs in the infrastructure, in the connections of the GPU servers and the storage systems. And you can see the tremendous latency difference, more than 4 times the performance on latency. And this is regular RDMA Ethernet we're talking about. This is the best Ethernet we can do with Rocky today. We turn on Spectrum-X, you get 4.5 times better performance. And here's what a AI workload looks like. So you can see the number of operations on the chart on the x-axis, and the y-axis is the latency. The green is Spectrum-X turned on, and the blue is the spread of latency. And the latency in operations like this means that the AI application is waiting for that completely across-the-board latency to go to all the different nodes before it moves forward to the next operation. So dramatic difference in performance you get, the efficiency, and again, that all relates back to making sure those GPUs are always busy. And with that, I'm going to turn it back over to Rob.
Yeah, and great. Let's jump into that, Steve, because I think, again, building off of that, really, what you have going on at Micron, it's really good. So.
I mean, absolutely. I mean, there's such a huge connection between the GPU that Rob was talking about and really the components we provide in memory and storage. And so everyone wants to talk about purchasing the GPU in their Supermicro system. The thing is, as Rob was saying, it's all about GPU utilization. And the two resources that actually enable that GPU utilization are really memory and storage. And so what I have here is really a chart on AI memory and storage hierarchy. You notice that it's a pyramid. It's intentionally arranged so that the smaller portions on the pyramid in terms of total terabyte media density, it means there's less of it. And as you get to the bottom of the pyramid, there's certainly more of it. Now, at the top, this is directly attached to Rob's GPUs, so you don't need to purchase this. When you buy a GPU in a Supermicro system, you don't need to worry about that. It's already integrated, and you hear it called the high bandwidth memory, HBM3E, or graphics memory, already attached to that GPU. Now, the main memory is the next portion of the hierarchy here. We highly recommend high capacity DRAM DDR5, you want the fastest speeds because you want as much memory as possible for active utilization for the GPU. Very important. Now, sometimes these data sets are so big, you need every single memory channel full, and if that's not enough, you start to convert your PCIe storage sockets and use those for memory. We call it CXL expansion memory when you need to add even more terabytes of memory or fill more memory channels. Now, the storage portion of this in those GPUs, you absolutely need the world's fastest SSDs direct attached to the GPUs. And so we actually have both those products today. We had the world's fastest Gen 4 SSD, the Micron 9400, and now just announced recently the Micron 9550, world's fastest Gen 5 SSD, explicitly designed for GPU feeding, AI training, and caching. And that's going to be directly attached. Now, one of the fascinating portions of this, and this is really my part of the world, high capacity SSDs. Rob talked about this with networked data lake storage. That's why you need the 800 gig NIC that he was talking about, because you have these huge data sets, these data lakes, 30 terabytes up to 100 terabytes, sometimes more, and we're moving massive chunks of data through the network, which is why the network is so key. The other piece is this is the largest portion of the pyramid. This is also where when people are buying a Supermicro system from William and the team, sometimes people skimp on this. They think, oh, I'm going to buy the GPU, that's what matters. What matters is how utilized you keep that GPU, as Rob was talking about. And if you're not storing your actual data sets on SSDs, which for the price you're paying for a GPU, it's dwarfed. The cost of SSDs is like a rounding error. There's no reason not to do this. I'll talk more about that later today. But you want high capacity, you need affordable, and you need ultra energy efficient because you want to apply your power to the GPUs, not to storage. And also AI inherently is not really a scalable, sustainable technology. It uses a ton of power, takes a lot of space up. Let's do that environmentally steward. Let's really do that in a good way. And then every single piece of this hierarchy you see here is really a core value proposition of Micron. We lead the industry, every area, every single one of these products is the world's most energy efficient in its category. And we really partner with Supermicro on that. We know they make a huge deal about sustainability, as they should. It's a big pillar for Supermicro. It's a big pillar for us. So we're happy to be here today and to continue to support Supermicro.
I think this is really brings it all together with some of the stuff that Jon has, and we'll keep moving into what Cloudian is doing on top of the SSDs and bringing it all together.
Absolutely.
Yeah, and in your intro, Rob, I mean, you touched on the complexity that's inherent in this environment as you're dealing with this large amount of data across these diverse workflows. And that complexity is exactly the issue that Cloudian addresses. So what Cloudian is storage software that runs on industry standard servers, Supermicro, of course. They can be HDD based or, of course, flash based, and we're seeing an increasing demand for that kind of servers, and we do a lot of work with Micron on that, and it's been great. We've announced some terrific performance results with Micron. But this is software that runs on standard servers, and you can start with a small number of servers, as few as 3, and then you can grow that limitlessly within a single storage environment. And that's what's really important, is we create a data lake that can be limitlessly scaled so it can accommodate as much data as you need, up to hundreds of petabytes within a single storage environment. So what this means for your AI workflow is you've now got a single source of truth, an S3 compatible storage pool that you can use for all your different workflows, from data ingest to machine learning to data analytics to deploying your model. All these workflows can be occurring within a single, limitlessly scalable data lake. And the data lake is accessible via parallel transfer from all these different devices, so we really get at the performance issues that you were talking about, because you can achieve parallel transfer across this entire environment. So that just makes it scalable on every parameter. It's scalable on capacity, it's scalable on performance, and it's highly reliable, highly secure. Cloudian is, in fact, the leading supplier of this class of storage software, enterprise-grade S3 compatible storage. It's military-grade security. 4 times it was named a Gartner Peer Insights Customer Choice, which is their kind of like their customer review site on Gartner. And what the customers say they really like is, the scalability, the security, and the S3 compatibility. And that really matters with these AI workflows, because think about it, a lot of this dev work you're doing right now on AI is being done in the cloud. So it's already being done with object storage as the back end. As Rob said, it's the largest storage environment in the world. The reason is that it's the most scalable storage environment. So all these tools work with this environment already, like Kafka, Spark, TensorFlow, PyTorch. They all work with object storage. You can go to our website and you can see tutorials on how you can integrate them all with Cloudian. But that means you can now have this single data lake environment that can be shared by all these different workflows. So what this does, getting back to your initial point, fixes the complexity problem. Because you have a single source of truth, one data lake that can be shared amongst all these different workflows, there's no migration of data between layers, you're not moving data from server to server. And that's where the complexity really comes in when you're managing huge amounts of data, is having to manage that data yourself, right? You have to move that data around, have it where you want it, when you need it, because you don't want anything lying fallow, you don't want any GPU sitting idle for a second. If you're having to move data around, you're creating a management complexity problem for yourself. We put it all in one single data lake that is limitlessly scalable. This is proven in multi-petabyte deployments with our customers worldwide, from single petabytes to tens of petabytes to hundreds of petabytes in a single environment, in virtually every vertical you can think of, from automotive to healthcare, finance, retail. One of the largest car companies in the world has standardized on Cloudian as their object storage worldwide, so it's deployed globally. In finance, one of the major credit card companies uses Cloudian with all-flash storage for fraud detection. Really important central workflow in their processes. And healthcare, many of the largest data repositories for healthcare imaging reside on Cloudian. As a matter of fact, in the US, if you've done an MRI in the last 2 years, 3 years, there's an excellent chance that MRI is now sitting in a Cloudian data repository. So what these customers really like is the fact that this is highly S3 compatible, so it works with their S3 workflows right out of the box. And that reliable operation is really what they're looking for. They want to know that it's going to work with their S3 applications. Our SDK, our S3 SDK is the AWS SDK. So we are committed to staying fully compatible with that environment. As a matter of fact, we are AWS's chosen partner for their AWS hybrid edge deployments. So for AWS local zones and for AWS outposts, if you want to have local storage with S3 compatibility, the solution is Cloudian. So you can go to the AWS marketplace and you can see this. You can see AWS's solutions, both software and appliance-based solutions for local zones and outposts. And of course, it's not only easy to use, it's also easy to buy. So we offer software that you can run on the hardware of your choice, and we offer complete solutions with software, hardware, and support you can buy either from Cloudian or from one of our valued partners. And I'm really pleased to announce that now Supermicro is one of our valued partners here. So you can go to Supermicro and you can buy a complete solution, hardware, software, and support, all from Supermicro under one roof. So in summary, this is a highly compatible, highly scalable environment that addresses the performance issues that Rob was talking about, and once and for all fixes the complexity of managing S3 storage within a single scalable data lake.
Yeah, no, I think that's a big piece of it, because unstructured data, sits in object. It also sits in file, especially when you start to get into some of the AI deployments. And I think bringing the whole solution together in simplicity is what the end users are looking for. We hear that from organizations all the time.
It is the biggest issue, is complexity.
Yeah. So let's bring it back into that unstructured area with Weka and Shimon. Why don't you take us into what Weka's up to?
Brilliant, thank you. So if the way Weka looks at the world is, if we're looking at the infrastructure triangle, compute, networking, and storage, we're seeing that in compute, there's been, in the last 10, 20 years, there's been massive advancements. Definitely what Rob mentioned with GPUs containing now thousands of cores, with a single server now doing more than 10 racks of servers in legacy HPC high performance environments, right? So suddenly you have a single server that now needs to get as much data or 10 times more data than single servers in the past. So you need to feed these servers, these cores, with data in order to get the value out of them. Next part is the networking. The networking, if you also look at the last 20 years, have also been massively renovated, right, or improved. 10 gigabit going to 100 gigabit, going all the way to 800 gigabit and more. Basically, Ethernet and InfiniBand are currently ruling the networking infrastructure. Fiber channel has been antiquated and obsoleted a bit. But there's been massive improvements. So compute and networking have been massively improved. But then storage, when you look at it, definitely we have partners like Micron that are completely improving component storage, the NVMe's and the SSDs, so that the component storage becomes faster and faster, and therefore faster NVMe's within the local servers. However, if you're looking at a distributed storage environment, there were not a lot of massive improvements. We still see a lot of parallel file systems that are great, but they've been created to solve a problem that existed 10, 20 years ago, where networks were slower and compute was actually slower as well. That's why they're using a lot of data locality, a lot of different moving parts. We're also seeing a lot of NAS appliances. Again, modern NAS appliances still, but it's more of the same. NFS is still NFS, even the newer versions of NFS, and even if you can get a bit more throughput, what about IOPS? What about metadata? How about low latency, right? So we're still seeing compute and networking being the thought leadership in AI workloads, and then the storage is almost like an afterthought. This is where Weka actually comes in, where we completely designed our file system from the bottoms up. We disregarded any existing architecture designs, a metadata server, NAS heads, even downward to the protocols. And we completely renovated and designed the Weka environment for flash technology, for running on flash technology, and therefore our data structures, our algorithms, our distribution, our protection. It allows us to do things that are unsolvable by existing environments, and we'll talk about how that's important in these environments. Eventually, if we're looking at an AI pipeline, this is a very simplified view. It's actually obviously much more complicated, and definitely if it's AI or Gen AI, if we're looking at a pipeline where it goes through ingesting the data, pre-processing the data, retraining and checkpointing. Training and checkpointing is a massive problem in AI, validating the data, which is eventually an inferencing workload, inferencing on new data, all the way down to archiving the data. We see currently customers using multiple different storage environments. Maybe they're using an object store for high capacity ingest, and then they're moving it to a parallel file system for pre-processing the data, cleaning, tagging, and enriching, and then training, copying the data, actually, as Rob mentioned, to local NVMe's on local GPU servers, validating and inferencing, which is basically in the GPU memory, but do have storage challenges that I'll be able to mention, all the way down to moving the data to archiving. Throughout this pipeline, which exists everywhere, throughout this pipeline, there's a lot of data copies. Data copies means that you need to manage multiple storage environments. You need to spend the effort, the time and the effort to move the data between different environments. And eventually that's time where your GPUs, your CPUs, your users, your business value is not progressing. And complicating it even further, even though there's each pipeline has multiple challenges, your storage experiences multiple pipelines concurrently. So even if I'm looking at the different requirements for different steps of the pipeline in terms of protocol, but also in terms of I/O patterns, some are read intensive, some are write intensive, some are IOPS intensive, some are very low latency required, right? Your storage experiences multiple of these pipelines concurrently. So there's no environment where you're saying, I'll just optimize my storage for training or pre-processing, because if you do, you now need to copy the data between these different environments, and that's a huge challenge, cost, time, effort. This is where we position Weka. This is where we see Weka actually helping customers, because what we're saying is Weka supports multiple protocol interfaces all to the same data, and that's unique. You can work with the data in all of these protocols. So for example, ingest the data using S3, then pre-process it using POSIX, then train using GPU direct storage, then archive or move it around using SMB. And the ability to say you can access the data using all of the protocols means that you flatten your pipeline and you don't need different moving components. But that's not enough. In addition, we're saying that the performance, and that's the way we designed the system, the performance of the Weka environment is such that it's even faster than local NVMe's. And that's massive because it means you don't need to move the data because of different protocol requirements. Plus, by not moving the data, you actually, and working on the data on the shared Weka environment, you're actually accelerating your output. I'll give you an example. A customer, a large autonomous car company, they're training hundreds of petabytes on Weka, dropped their training epoch time from 12 days to 4 hours. It sounds like a lie, I know, but that's quantifiable, that's measurable. Another public use case is another customer using their training epoch time was 7 days, dropped to 2 hours. And there's more. There's a lot of these examples. We're in the AI space for many years. So in terms of protocol compatibility, there is no need to have multiple storage, S3, NFS, POSIX, GPU direct storage. We even added HDFS for Hadoop and Spark recently. Definitely containerized environment. In terms of performance, again, faster than your local NVMe's. And again, when we talk about performance, it's not only what's my read throughput. It's also how many millions of IOPS, what's the low latency, how much metadata at scale. And then the final piece is the price. Obviously, it needs all to be economic because you don't want to be like only the tip of the high-end capacity. So the price is very compelling. We're definitely working with our partners with Supermicro and Micron on larger capacity, cost-effective drives. And definitely with our partners in Cloudian around our ability to virtualize the capacity of the entire environment by an object store. So imagine putting Weka flash capacity and behind it a large object store. So Weka manages the whole data movement if needed. And that obviously is cost effective at scale. I'll finish with this, and I know this is a bit of an eye chart, but I did want to provide a bit of technical raw data from the field. So this is something this is an analysis of one of our AI customers. And we have many of those. And they all go towards the same numbers here. So what we're seeing here is that we looked at a storage system, as I mentioned, all getting multiple pipelines concurrently. This is a system that runs 1,019 GPU servers, so approximately 8,000 and more GPUs. Looking at it for the last 2 days, we're seeing that the way the storage experience, the AI workload, is approximately 50% writes, 50% reads. So this notion that AI is only reads doesn't materialize here, obviously. And also, if we're looking at the I/O sizes, we're seeing that the I/O sizes the writes are, in this case, they're 40 kilobyte. Usually, we're seeing 40 kilobyte to 140 kilobyte write sizes. And if you look at Parquet files and data structures, you're seeing that explains it. Definitely, when you're looking at checkpointing sizes at scale. And then when you're looking at the reads here are anywhere between 350, and in other customers, we're seeing that go all the way up to 500 kilobytes. So tiny writes, small reads, 50% reads, 50% writes. That's a typical AI I/O pattern. This is a computer video environment, a computer vision environment, NLP, NLU environments, LLM training and inferencing at large scale. So our message here is you need a storage that can accommodate that. If your USB stick can do that, great. Probably it cannot. That's where Weka really accelerates, because if you're suddenly only read intensive or only write throughput intensive, you have a problem, because when you mix those IOs, everything will slow down. That's why Weka is really optimized for these solutions, for these challenges, for these workloads. And the end result, and I'll finish with that, the end result for the customer, getting your GPU from, and we have numerous of this example, around 30% utilization, all the way to 70, 80, 90% utilization, finishing your business value faster.
Yeah, I think that is exactly one of the things, and again, it's always great to bring the tech in and the reality into this, is that you don't know what you don't know about your I/O workloads, especially when you get down to that, and how to keep and feed the GPUs and keep everything going quickly. But let's let William bring us home here on the presentation section of this. Kind of give us an idea around Supermicro bringing this all together.
Yes, Rob. So Supermicro now is a total solution provider. We offer a comprehensive product portfolio with all the great partners here for the AI application use cases, right? So with the advanced NVMe and GPU technologies, we are able to deliver the total solutions with totally software-defined storage solutions with WekaIO and Cloudian. Also, we are seeing a tremendous amount of AI requests from the industries. And we have been deploying all the GPUs machines worldwide. We are the largest GPU providers in the world right now. And that's why we have been working with all these great partners for a long time to deliver the total solutions, including GPU, storage servers, HPC, as well as fastest network devices. And that's why today we are going to talk about a multi-tier storage solutions where it's powered by NVIDIA GPU, WekaIO and Cloudian software, as well as Micron's technology. Yeah, as you may know, AI needs data, especially fast storage where residing data. So without the fast storage, those AI will be slowed down. They will need to wait for the data to fit in, right? And that's why we would like to introduce Supermicro reference architectures for the AI use cases. And as you can see here, we provide a scalable reference architectures for the AI use cases. It could be used for AI, LLM, large language machine training models. And the reference architectures features 3 tiers. The first tier is application tier, equipped with all the NVIDIA HGX GPU. And you can see there are 4. We populate 4 GPU systems per rack to accommodate all the GPU computing resources. If your data center is liquid cooling ready, we are also able to introduce liquid cooling solutions with the GPUs. They will make the solution with a double density of the GPUs. That means we can have up to 8 GPU servers per rack to fully utilize the rack space in the data center. For the second tier, we have the high-performance storage tier powered by Weka and Micron medias, where we use Micron's 6500 media a lot, and that's very good for both cost and performance balance design. And the last tier is data lake storage tier. We use top-loading servers. As you can see here, we also work with Cloudian to implement the solutions. So Cloudian actually they can work with Weka without any compatibility issue. Weka will manage the tiering, the auto tiering policies. They can move the hot data and cold data in between the all-flash and the hybrid storage systems here. And that's why we are able to provide the end-to-end solutions all the way from top of the GPUs down to the bottom of the hybrid shared storage. And as you may know, those GPUs has local data, but if you are running all those AI application training models, the local data won't be sufficient for you to deal with all the daily workloads. So you're going to need a shared storage like Weka and Cloudian here. So all the GPU resources can simultaneously access the shared storage and use the shared data to process their AI training workloads. Yeah, and also. Just FYI, we recently just deployed the largest direct liquid cool GPU solutions in the data center in the US. That's the largest one, I would say, nowadays. Yeah.
Yeah. No, I think that's great, and I think these reference architectures help to bring everything back together. And I think one of the things we should do here is dive a little bit deeper and continue to ground people on what's going on. First question is going to go to Rob. What are the benefits of the NVIDIA DGX SuperPod certification?
So an NVIDIA SuperPod is a complete data center scale AI supercomputer. So it's supercomputer in a box, a very big box.
Yeah.
And that means that when you buy one and you put it into your data center, you know that it's already been tested completely in the factory. It's already been integrated, networking, cables, GPU servers, and storage. This is the storage summit, so let's go deeper on the storage. The storage has to be certified to be SuperPod ready. And there's a handful of partners, Weka is one, that are certified to be storage for SuperPod. And that testing is not easy. It's not only performance testing in both directions at very high levels. There's also, besides bandwidth, there's latency. And then most importantly, AI workloads are tested as well. And you have to meet the specification to be able to become certified and part of a SuperPod from a storage perspective.
Because it's important to keep the GPUs busy, I would assume that's
absolutely,
really, yeah.
Absolutely, and at the performance level, right? Someone who buys a SuperPod doesn't want the storage to be the bottleneck in their AI applications, and their AI applications are so broad. You have to really test all different kinds in order to make sure the storage can support all the different workloads that it'll see.
So jumping into the next question, I think Shimon, he just mentioned you, right, about SuperPod certification. How does Weka really optimize for AI? And how does Weka incorporate all the key solutions like NVIDIA, Micron, and Cloudian into that solution?
Brilliant. So Weka is software only, right? So definitely we're using our Supermicro partners, and we're installing on their servers, and there's different types of servers that are supported, right? Different models. We're benefiting from the Micron local SSDs, local NVMe's performance, because eventually we're using the servers as a block layer, and we're distributing all of our blocks down to the granularity of the location of the NVMe's that they'll be placed on. So the faster the NVMe, the better, definitely. And with Cloudian, our Cloudian partners, we actually have customers in production utilizing Weka that then virtualize the capacity to a Cloudian object store for a more cost-effective capacity tier. With regard to the NVIDIA partnership and with regard to how does Weka optimizing all of that into AI, I think I mentioned a bit of it before. If we're looking at AI use cases, the capacity is tremendous. If you're looking at training, it could be hundreds of terabytes. We have customers at hundreds of petabytes for training data. Due to all of the stages, you gather everything, you need to mobilize that data worldwide. So the Weka data movement capability comes into play as well. And then you need to look in that data and see what's relevant. That's a very read-intensive, write-intensive workflow. So the ability to provide all of those I/O characteristics. On top of that, we're optimized with GPU direct storage. So Weka supports GPU direct storage, accelerating that even further, and also dropping the power utilization and allowing some customer CPU cores to be even further available. As Rob mentioned, the SuperPod certification is more than just how fast are you. It's how fast are you, how reliable are you, are you integrated into the operation environment that NVIDIA provides as part of the SuperPod? So that was an interesting testing that we did. And we see that in the field as well. So the ability to answer and work with multiple mixed workloads at scale while moving the data between different locations, eventually feeding the GPUs significantly faster.
One thing I'd add to that, so SuperPod is the high end, right, the Cadillac, but there's an awful lot of implementations of GPU systems. We call them reference architectures that aren't SuperPod. But if you're SuperPod certified, that gives the customer a good feeling that if they can do the Cadillac, they can probably do the Volkswagen.
Yeah, definitely. More confidence is better. That's for sure. But hey, let's dive a little bit deeper with Steve, and let's understand what's driving the industry's transition from HDDs to SSDs, or SSDs. I knew I would screw that up at least once today, but for, especially.
As long as someone buys one from William, we're good.
Yeah, absolutely. And I think when you look at networked AI and data lakes, they're really, SSD heavy, right? So which SSD attributes are really the most and least important when you get into the high capacity SSDs, and what are used for AIs and data lakes, and how does the Micron 6500 Ion really uniquely leverage enabled, best-in-class designs to help with AI?
Well, you know what's interesting? I think, and I don't know what you guys think about this, the HDD to SSD transition is a fairly recent phenomenon in these networked data lakes, where before people would buy the GPUs, but they would underinvest in their storage. And I think about key themes that this panel is talking about. It's the scale that Shimon was talking about, the sheer scale of these systems. What Rob is talking about is the network. You got to feed the network. You got to do it using the least amount of power. It's got to be massive, and everybody is there. I think as an industry, we got to start thinking system level like this and really think about start at the pipe and almost work backwards. So that's why you're talking about what's driving the transition to the all SSD, all high capacity. A couple of things there. The data set sizes, as Shimon mentioned, are just getting absolutely massive. You need more storage. There's more going on in those things. Rob and I were talking about parameters and stuff. Parameter growth is huge. You've got those things. Shimon hit on epoch time, which is really fascinating earlier too. This is ultimately about, if we start at the pipe and work backwards, if this is our bottleneck and the speed in which we feed that pipe is the bottleneck, we have to use SSDs by definition to keep the GPUs utilized. You just have to do it. So that performance piece, and when you feed the performance, you can now, with our 6500 Ion, which all of us, it's like the invisible force powering all of this behind the scenes, because that's where the data lives. It starts with where it lives, and then the memory it moves through. But on that product, we can actually ingest a 100 terabyte data lake 4 days faster than a hard drive. And so if you're not spending the extra money, which again is a rounding error and compared to the GPUs, like buying the big network and buying the SSDs, they're going to feed it, and use the best of the best. So other things driving the transition for us, the claim to fame with the 6500 Ion, it's the world's most energy efficient 30 terabyte SSD. You can fill one of Williams' servers, pop 24 of these things in at 2U. And you're going to use about 50% less power than any other 30 terabyte QLC class SSD on the market. And then you look at HDDs, they only cap out at 30 terabytes now. So you can store more drives per U, and you can use 50% less power to 6500 Ion. There's a lot of all these kind of trends.
I think I never thought of that. Well, we're all in. That's great.
Yeah.
Go for it.
I think one thought I have about it, that we're constantly talking about performance, throughput, and IOPS. In AI, we're seeing a lot of importance for the latency as well, and I think that's huge. Driving the shift to NVMe's obviously as well, because imagine even an inferencing environment where you have a model repository and you have hundreds of terabytes of models, versions, variations of the model, fine-tuned models, or just models that you download. You now need to feed your inference environment. You need to feed the GPUs through the network usually, right? Or if you're trying to do something else. Or local, but then you need to feed hundreds of
That's
of terabyte into. So you need to feed the GPUs with the model so they can inference. And your business value is how fast can your user get an answer to their prompt. So how fast can you mobilize a model into the GPU memory, answer the prompt, and now in many cases you're not using only one model. You now have a chain reaction of models piping into each other. So how fast can you load and unload models? Latency of NVMe's is definitely important.
I think with the fast Micron media, we were able to see how the customers shorten their developing time and also how they save their energy for their data centers.
And one thing I would add is that we've been working with Micron and the other SSD vendors for a long time with AI models running in their labs while they're designing those SSDs. So there's a lot that happens 2 years ago before it comes into what we're talking about.
You're seeing the reflection of that now. And really this the inflection point now where you got QLC and QLC class medias like this, where we can effectively sell a next layer drive count TLC levels of performance at the price of QLC. It's a breakthrough moment.
And the amazing thing about it is you look at the speed of the technology advancements. So we're talking about Gen 6 SSDs now, and the rest of the industry, the x86 industry is talking about it 2 years from now.
Yeah, what, HBM4 too? I mean,
exactly.
we're working on that.
It's just pushing the technology.
We announced performance results with Micron. Were very impressive, but I think what was even more impressive was the efficiency we announced. It was twice the efficiency of previous solutions, and that's really, for our EMEA customers in particular, where they're really conscious of power consumption, huge selling point, because that power per terabyte per minute really matters.
Yeah, and I mean, that's where, I mean, there's a lot of choices in storage, but why object? Why don't you kind of bring us?
Yeah, right, exactly. So why object? And I think this is a really good question, because it's not necessarily the one that comes to your mind first, but among the three storage types, block, file, and object is actually the newest on the scene, relative newcomer. But it is the largest storage environment, and the reason for that, of course, is because it was adopted by the hyperscalers as their dominant storage environment. The reason why the hyperscalers use it is exactly the same reason why it makes a lot of sense for AI. And if you look at the AI training models, we've been talked a lot about capacity. Capacity of these models is increasing at 70% per year. So that means whatever size your training data set is now, it's going to be a heck of a lot bigger 5 years from now.
The more data, the better the model.
More data, the better the model, and everything is growing, and it's growing really fast, much faster than other data types. So you really need to think ahead to how you're going to manage that capacity, and where is that capacity stored that it can be manageable. So what our customers look at is, really the three things I think distinguish object storage. We call them the three S's, S3. The three S's are scalability, security, and of course the S3 protocol. In terms of scalability, the fact is object storage is managed differently. It is a different way of managing your data. It's a flat address space, and that flat address space simply means that it can be scaled limitlessly. There's no limit on the growth within a single environment. And it can also be geo-distributed, and it can also be accessed in parallel. So when you're running all these different Supermicro servers with their Micron storage, you're accessing them all in parallel. And we're working on some great stuff that's going to make that super fast into the GPU environment with that parallel transfer from all those nodes. So there's going to be some really exciting developments coming down the road. So that's the scale side. On the security side, the most recent survey I saw said that security was actually one of the top concerns for deploying AI in enterprise settings. And of course, this makes sense because you're putting your crown jewels in this model. Object storage was designed for security because it was designed to be internet connected. Right? We are designed to go on the open network. It better be secure. So we have a ton of security certification. Security is built in from the first minute. And it's also very easy to achieve data mutability with object storage. So we can protect data from ransomware, which continues to be a threat even after all these years. You still see ransomware attacks all the time. So the fact that you've got security and ransomware protection is the second key pillar.
Well, and on the ransomware piece, there's also a huge workload for high-capacity drives, and it ties all of us together on your rebuild times. How fast do you recover from those attacks? Right. That's a huge growing workload.
Yeah, exactly.
That I think all of us are seeing.
Yeah. Right, exactly. So, protect your data, rebuild quickly. But then the third pillar of it is, S3 API itself. And you may think, well, this is just another storage protocol, but it's different in that the S3 API was the storage protocol of the internet. It was the one that was designed for usage on the internet. So it was designed for large-scale data transfers over long distances with sketchy network connections. So it was designed to be robust. It is an immensely complex protocol. So maintaining adherence to it is difficult. So that's why we use the AWS SDK. But the S3 API is really the underpinning of this large-scale data management that really sets object storage apart. So really, those are the three things: is the scalability, security, and the protocol.
I would sum up object storage in one sentence. So why object storage? because that's where the data is.
That's where the data is.
I think that's so true, and let's bring William into this and really talk to the fact that, again, bringing it all together, right, is a big thing, and you guys are really, laying out what this is going to look like in the future as well.
Yeah, so we are always trying to design and optimize the GPU and storage solutions. That's why with NVIDIA HGX systems, we make it every 32 systems as a scalable units, so where you can scale your solutions as your needs. And on the storage side, we also make it totally software-defined as a scalable reference designs, right? So, for example, we recommend customers to have a more cost-effective design with 1:10 all-flash and hybrid ratio, hybrid high-capacity ratios. For example, if you have a needs of 25 petabyte storage requirements, we will recommend you to have 2 petabyte all-flash in the front with 25 petabyte object storage like a Cloudian as a data lake to reside those large data sets. So Weka will be able to provide a single namespace to manage all the data lake and all the hard data and cold data. They do implement the auto-tiering policies. So you don't need to worry about when you need to move the data in between those cold storage and hard storage. And that's why we make it totally compatible and flexible as a scalable units.
Yeah, so let's kind of bring it home with what the customers should really be thinking about, especially when they look at the cloud versus on-prem decision.
From the perspective of feeding the GPU, definitely on-prem, right? Because if you go wide area, from that perspective, you're not going to meet the data movement requirements. Now, if you do that ahead of time, like we've been talking, where you've staged it, then you're fine. And then it doesn't matter which protocol, as long as the network is up to the task.
Mm-hmm. Yeah.
And the network parameters for AI are different than typical workloads, right? Because it's not only bandwidth, but it's also, as we said, latency, right? And latency matters. Mm-hmm. And so you need technologies like InfiniBand, like Spectrum-X Ethernet that keep that latency low, as well as providing the high bandwidth.
Anybody else want to chime in on that? Or?
So security is one of the factors, yep, right, for the decision makers. Also, if you are talking about total cost of ownership, you're going to need an on-prem to host your data, and then it's like you are renting a house, and you want to buy a house for your own services, right? And you can do whatever you want. You can develop all your applications and change the configuration, optimize it as your needs. Yeah.
Yeah.
Yeah, we see security as being a key driver for making that on-prem decision. Performance would be another one. Cost, it just tends to be lower cost to manage your own infrastructure. But the other beautiful part about this is with object storage, you almost have independence. You can make your decision as you fly because we can operate hybrid. So you can operate cloud storage and on-prem storage, and they can work together in a hybrid environment. So you can run some workloads on-prem, you can run some in the cloud. You can even run some remotely. We're seeing a lot of interest in people deploying workloads at the edge. Get the data, get the compute closer to the sources and uses of the data. So we support hybrid in terms of being out at the edge, either with Supermicro infrastructure or or AWS. Support it in your own data center, again using your choice of hardware, and then in the cloud it can all operate with the same tools and the same storage protocols.
And in clouds where the GPUs are in the cloud with the data, then you don't have an issue. It's only if you're trying to move the data to where the GPUs are.
Maybe I'll talk about that because that's actually something that we're seeing a lot. And I think, first of all, you don't have the problem in the cloud when you can feed the GPUs sufficiently. We're actually seeing that in cloud environments, there's subpar storage solutions, talking about the challenges that still moves the on-prem challenges of feeding the GPUs with enough data to the cloud environments. We actually have some customers that started on the cloud, moved from whatever they used to Weka on the cloud, their GPU utilization increased. But then they also take that data on-prem. So to me, it's like cloud or on-prem, both what is a cloud? Is a cloud multiple data centers? Because the reality is that in the future, and the future is now, it's not even like 5 years, today, a year from now, and going on, everything is distributed. No real business is going to have one data center, two data centers. That's it. You're acquiring data from worldwide environments. Maybe I'm S3ing it into an environment from thousands of IoT devices, trains, cameras, cars, right? And then I need to mobilize that data across geos, maybe to an on-prem environment where now I can feed my GPUs on training on it. But then when I'm inferencing on it, maybe I'm putting a lot of inference edges. So different environments would accommodate for different use cases. Definitely being on-prem for the long term, for the sake of how fast can you feed the data, because, for example, the technologies like GPU direct storage exist mostly on-prem. Maybe there's one hypervisor.
Better TCO.
Yeah.
Exactly. So eventually that translates to when you're on-prem, you can benefit from the latest and greatest, while with the cloud vendors, at some point.
Well, and I also wanted to touch on the SLAs too. So as you're looking at that, I mean, I think when you actually do this comparison yourself, and you compare a solution, from William using all of these different components we're talking about, and do the TCO analysis yourself. What's the performance per terabyte, per watt, per dollar, per rack? That's kind of how to think about these ultra high capacity deployments, and do it with the best network, do it with 6500 ions, do it with the best components, and price it out, and then do that analysis yourself. Compare that, you building yourself a best in class GPU architecture versus what you could get on the cloud, and you really got to look at those SLAs. They are doing the GPU feeding for you using their own infrastructures. Now Micron, we service everybody, right? But it's about you, it's about your business, and also, is it a competitive advantage to have the added speed control?
I think it's important to understand that, let's say you've got the best GPU, but you don't put in the best network.
Exactly.
Why?
Totally. Yeah.
Or you don't put in the best SSDs.
Yeah.
Why? You just spent all this money on this GPU that's like a Ferrari parked in your garage you're never driving.
I mean, do you like that idea, Rob, of have them price out the TCO? For the folks at home watching, do your TCO analysis, build the best, and then do the compare.
And I think one of the things, the big thing is, a lot of this is the data is their crown jewels of these organizations.
Absolutely.
And do they really want to move it around all that? And sometimes you could have competitive nature where you're in the security aspects and the privacy aspects where you can't even move it around and things of that. I think this is a great place to kind of wrap it up. I want to thank you all for really being on here, because I think this has really given everybody just a clear idea of how to think about AI and AI infrastructure and what the storage layer and data platform layer really needs to be. And I want to thank you all for watching this session. Keep watching the Supermicro X, and you'll be able to understand what's going on. Also, note our next session will be AI and the future of media storage workflows, innovations for the entertainment industry, tomorrow, August 14th, 2024 at 10 a.m. Pacific. Thanks for watching this episode of Enabling AI Data Pipelines, Optimized Storage for AI on theCUBE, and stay tuned.